Okay, here we go. Last video for chapter 12. The Hubert curve. I kind of skipped over it, but now that I'm doing a third one, I might as well talk about it. This is a projection of oil production and use in the United States or in the world. So basically the idea is as time increases across the bottom, our oil production is going to, or oil extraction is going to increase until basically two things happen. We start to run out, and the price gets so high that people start using as much. We start to cut back and conserve because it'll save us money. And then you're going to see the production basically increase till it bottoms out at some point in the future, either because it's just too expensive to buy or there's just not any around anymore. So those kind of two things are working against us with regards to oil and a lot of the fossil fuels. Pretty soon their scarcity will drive the price up to a point where it won't be feasible to buy it. And at that point, a lot of our renewable energy sources will become a lot more feasible. A lot of the reason we don't use more renewable is a money factor. Right now, the fossil fuels are a lot cheaper to use than our new fuels. And the fact is, we don't make enough to want to spend more for energy than we have to. So we're kind of caught in that kind of catch-22, but that will stop in the future. Okay. So what is the future of fossil fuels? Well, who knows? It kind of depends. There's a lot of expectations or a lot of predictions that our petroleum will run out in maybe 40, 50 years. Maybe if everybody depends on what's going on. You know, we're developing hybrids and stuff, which actually allow us to extend that time. But yet there's a lot of countries where they're not using hybrids and they want more cars in their greater population, like India. So you never quite know. We think our coal supply will last us at least 200 years, maybe a little longer. Here in the United States, we still have a lot of coal. So that's a good chance. But again, we have to do a lot of environmental damage to get to it. So, you know, at what point will the price be high enough for coal that we actually start looking for other resources is questionable. Who knows? But you guys in your lifetime may see us running out of petroleum. Okay. The other type of non-renewable you need to know about is nuclear energy, and that's nuclear fission. Basically, we are breaking apart atoms. So you have uranium-235, and what happens is it gets bombarded by the neutrons from other atoms that have broken apart, and that neutron strikes the atom and actually breaks off fragments that release more neutrons. And so basically you're degrading your uranium to plutonium, which is where we get our dirty bomb plutonium or radioactive material. So that reaction of the release of electrons and the breaking of uranium into smaller parts is fission, and it releases a great deal of energy. So what happens is we have fuel rods here in your core. And these, we have to control the reaction rate because we don't want the rate to get out of control and cause a meltdown, which is what has happened like in Chernobyl and Fukushima and 3 Mile Island. Those are three of the major nuclear things that have happened that you guys should know about. So we have control rods. These control rods kind of drop down in between the core, and they block the neutrons, and so they can slow the reaction. So if they drop down, they can slow the reaction or even shut it off. And if they raise, the reaction is going to be faster. So they're constantly adjusting to keep going up and down to keep this reaction rate at a certain rate so we don't have a meltdown. This heats the water around it. And this does not come in, the radioactive material does not come into contact with the water. It's just the water's around it, basically as a cooling system. But it absorbs the heat, and it comes over here, and this water does not come into contact with the water that actually turns into the steam. But the heat in this pipe will turn this water into steam. The steam rises, goes over and turns the turbine. Turbine turns the generator, and voila, we have electricity, just like we said with the coal. So again, this process is still the same. This water gets condensed and back it goes again to be heated up and go back through. This is a closed system. So the steam and the water in this system is closed, and then this system is closed, the one that really gets the water from the nuclear power or the nuclear reaction. So basically you have two closed systems, and these are not released at any time to the environment. Now this system, which cools the steam back into a liquid so it can be heated up again, this system does get dumped, okay? But this does not come anywhere near the nuclear reactor. So it is in no way, shape, or form contaminated and cannot be contaminated because it's a closed system within the system. So it can't. But when you see the big smokestacks from a nuclear power plant, the white stuff coming out of them is the white stuff coming out of those big stacks is not do we have a whoops, sorry. Is there a picture? No, I need a picture. It's not smoke, it's steam. So that's steam coming out, and again, a lot of nuclear reactors release hot water into the surrounding rivers or streams, and the reason they're usually built along coastlines or rivers and stuff like that is that, so that they have some place to dump the water. Here in Florida, we have nuclear power plants. The manatees love them in the winter where they're dumping the hot water out because they go hang out there. So, okay. So you have your fuel rods, and then you have your control rods. The fuel rods heat the water goes over, heats other water, makes it into steam, steam turns the turbine turns the generator, voila, you have electricity. Control rods, again, are there to kind of go up and down and control that reaction so that there's no meltdown. If something happened, the control rods should drop completely down and stop the reaction altogether. In Fukushima, after the earthquake, they did not predict a tsunami and thought they could survive it. And they should, but at the point of the earthquake, they probably should have gone ahead right at that point and just shut down their reactors at that point, but they did not. They chose not to, which caused a meltdown there because then they lost control of the reactors when the tsunami hit. Okay, advantages and disadvantages. There is no air pollution in the process of nuclear fusion or nuclear energy. However, in building the facility, there can be. In transporting the uranium to the facility, there can be. But in the actual production, there is not. There's no pollution. But actually, hot water is a thermal pollution, just to rectify that. It can also decrease our need for importing oil because, again, this is an electrical source, so we don't have to transport things that, that might need to be, it burns clean kind of thing. It is radioactive, so there is always a possibility of accidents, and we've had a few. And it's difficult, or it's not really difficult, but the disposal of the radioactive waste from these, because the fuel rods do kind of burn out after a while, they degrade to a point where we can't use them. And they have to be stored. Right now, they're usually stored on site. We wanted to store them and move them all to Yucca Mountain, but people had a fit about them being transported on trains and stuff like that, although it's done all the time. But so right now, all of it's basically housed on site, which is, it's perfectly safe. It's not a problem. They put them in rooms and stuff like that and just leave it. But again, nuclear also is a non-renewable. We will run out of uranium, but we can probably move to another radioactive material pretty easily for nuclear. Okay, so radioactive waste, like I said, we have to be careful. Most of it's kept on site in small rooms. I think in the movie Switch, we will be seeing that. So you have to be careful, kind of thing. You don't want anybody exposed. So, okay. By the way, low-level radioactivity is very common. But actually most power plant workers, they actually have little monitors and they very seldom register any radioactivity, so it's pretty good. Okay, nuclear fusion. If we could ever figure out how to do this, this is great. Nuclear fusion is what occurs on the surface of the planet. It actually does not necessarily require radioactivity, and it's taking two things and making them into one, which is happening with hydrogen and helium on the sun. It's basically an unlimited source of energy, but at this point we are trying, but it creates so much energy and heat to do it, we can't contain it. It's like trying to contain a mini sun. So if anybody ever figures out how to do this, then they will be able to power the world and be rich. So good luck if you want to try to do that. Okay, so that's it for chapter 12. I'm going to post this, and I will do 13 tomorrow. So I hope you guys are having a nice night, and I'll see you tomorrow.